Hello everyone, in this lesson, we will learn about Task 12. Star Delta start of asynchronous motor S7-1200 based on FC. The objectives to be achieved through this task are: 1. Memorize the 4 types of block structures. Organization block, function, FC, function block, FB, and data block, DB. 2. Explain the meanings of the 4 types of block structures and clarify the differences between FC and FB. 3. According to control requirements, correctly use organization blocks, function, FC, and data blocks to write control programs and perform online debugging. The knowledge system of this task includes 2 main parts. Firstly, understand the 3 programming methods of TIA Portal: linear programming, modular programming, and structured programming. Users can choose different programming methods based on the control requirements of the actual control object. Secondly, understand user program blocks, including organization block, OB, function, FC, function block, FB, and data block, DB. From a literal perspective, an organization block is a block that organizes the running of the program, including cyclic organization blocks, start organization blocks, interrupt organization blocks, etc. A function, FC, is a subroutine used by the user for calculations or logic, but it cannot store data. A function block, FB, is also a subroutine used by the user, which can store data, equivalent to FC plus DB. Data blocks, DB, are used for storing data and are divided into global DBs and local, background, DBs. Let's move on to the knowledge points, starting with an explanation of the programming methods in TIA Portal. The programming methods in TIA Portal are divided into 3 types: linear programming, modular programming, and structured programming. Linear programming is suitable for relatively simple control objects, where the entire program is executed within a cyclic organization block, OB1. Modular programming is appropriate for more complex control systems, which can be divided into many control units, such as conveyor belt A, conveyor belt B, sorting, and packaging. Each control unit can be programmed as a module and then called within an organization block. Structured programming is used when there are multiple repetitive actions required by the control specifications. For example, if a mixing pump needs to operate 3 times, the repeated action can be encapsulated into a subroutine block and then called repeatedly to simplify the program structure. Next, let's learn about the user program blocks of the S7-1200 PLC. In the project tree of TIA Portal, there is a program block group that displays various program blocks related to the project. OB30 is a cyclic interrupt organization block, OB40 is a hardware interrupt organization block, OB1 is the main program and is the most commonly used program block in practice, and OB100 is the startup organization block. These blocks can be added or removed according to the actual project's control requirements. FC1 and FC2 are functions, FB1 is a function block, and DB1 and DB2 are data blocks. In practical use and communication, FC and FB are also referred to by another name, namely function and function block, respectively, which have the same meaning. Next, let's learn about the function FC. Function FC is a type of subroutine used during programming to implement a specific function or algorithm. Since its execution process is completed within the program block, it is necessary to define interface parameters for the function, also known as formal parameters or local variables. Input is an input parameter, which passes the state of external input signals to the local variables of the subroutine. Output is an output parameter, which passes the execution result of the subroutine to external signals. Inout is an input-output parameter, whose variable data has input and output characteristics, or is used both inside and outside the subroutine. Temp is a temporary parameter, which does not exchange with the outside and only exists within the subroutine. Constant is a constant. Return is the return value of the program. During the use of function fc, two concepts are involved: formal parameters and actual parameters. Formal parameters refer to the parameters used in functions or function blocks, which do not have practical significance themselves and generally refer to local variables within the program block. Actual parameters refer to parameters that have practical significance and values, generally referring to global variables outside the program block. As shown in the figure, this is an encapsulated function. In the main program call, through the input interface of function fc, the value of the actual parameter is assigned to the formal parameter, such as the state value of start button I0.0 is input to start. Then, within the function, logical operations are performed by the formal parameter. After the subroutine execution ends, through the output interface, the value of the formal parameter is passed to the actual parameter, such as passing the value of power contactor to Q0.0, thus realizing the function call and data transfer. Finally, let's discuss the case study. This case involves the star-delta start of a motor, with the control requirements and address allocation table being the same as those in task 6. The overall programming approach for this case is to write the control program within a function fc and then call this function from the main program. To create the project, first create a new project and add a new device. Then, based on the address allocation table, write the PLC variable table. The variables here have actual physical significance and are actual parameters when called in functions, belonging to global variables. In step 4, double-click Add New Block in the project tree, select Function, rename it to star-delta conversion, and leave the language as LAD by default. Since function fc does not come with a background data block, it cannot save related data of the subroutine block. In this case, to record delay time using timers, a data block needs to be added to the project. In the project tree, double-click Add New Block, select Data Block DB, name it Timer, and choose IEC_timer as the type. In step 6, declare the local variables for function fc. Since the logic control for star-delta start needs to be completed within function fc, local variables, also known as formal parameters, need to be declared for this function. First, define 4 input variables in the input section: start, stop, overload, and time. Notice that time is of type time. In the output section, define the star contactor variable. In the inout interface, enter the power contactor, delta contactor variables, and timer, with the type being IEC_timer. In step 7, write the ladder diagram in fc according to the control requirements, as shown in the figure. Since the variables of the subroutine are local variables, each instruction in the ladder diagram only displays the variable name without an actual physical address, automatically adding a hashtag sign in front. In step 8, drag the fc block directly into the program segment in the main program and match the actual parameters for each formal parameter interface. The entire program is now complete. After compiling without errors, download it to the PLC device for debugging and running. 3 programming methods of the TIA portal and the types of user program blocks are introduced in this lesson. Using the star-delta start as an example, we have explained the specific steps for programming function fc. You are encouraged to practice more. Thank you for your attention. See you next time.